Okay, let's go over this practice test for Chapter 2. A lot of material in Chapter 2, but this practice test covers the highlights of what we need to know. All right, this first question says, determine whether this is a function or not. Well, I need to know if it passes the vertical line test. Okay, so I can solve this for y, and I go, oh, I've seen that before. That's a parent function of a square root, and it has a horizontal stretch to it. So it's going to take my square root function and stretch it horizontally. But here's the big deal. We have a plus and we have a minus. Right, so literally I have two functions. I have a plus root 5x and I have a minus root 5x, which means that for every positive point, I have a reflection, because that's what the negative sign in front of the function is going to do, like that. And we can see that this does not pass the vertical line test. So this is not a function, all right? But there's an easier way that I can look at this right here. I can look at the exponent on the y. Is it an even exponent? The answer is yes. Then it's not going to pass the vertical line test. It's not going to be a function. Evaluate the function. What do we mean by evaluate? When you see this word evaluate, what it means is it's going to substitute. So what this means is this equation, this function, for every x, I'm going to plug in x minus 2. So this is just a substitution. Go ahead and FOIL this, collect like terms, and then you have the answer to that. Difference quotient. All right, we did not do that. We did rate of change instead. Okay, piecewise functions. Okay, this still seems to give people a lot of problems. All right, I'm going to cover two things. This says determine f of 6, but I'm also going to talk about, you might have a question where you need to graph these. Okay, when you need to graph them, you can just think of these as two y equals mx plus b's and plot them, which is what I've done right here. Okay, here's the first one, and here's the second one. And let's take a look at the intervals which each one of these are valid for. Okay, 4. Less than 4 and greater than 4. That's my big deal. So what I did is here at x equal 4, okay, I can see where it crosses both functions. Well, this function right here, it says that this function is only valid if x is less than 4. So anywhere I see the function, this function greater than 4, I want to erase it or get rid of it. And I'm going to put a circle right there at x equal 4 because this says that x equal 4 is not included. I have to be less than 4. Okay, now let's take care of this one. Now this one picks up where the other one left off. This function is good for all x's greater than or equal to 4. Okay, not much left of this function right here, but what I'm going to do is I'm going to put a solid circle here, and then this function is good to go for any x greater than or equal to 4. And then I'm going to erase all of this. And then I have my piecewise function. That's how we graph our piecewise functions. Okay, now this asks something a little bit different. It says determine f's of 6. So that means my x value is 6, which is certainly greater than or equal to 4. So what am I going to do? I'm going to take the 6 and I'm going to substitute it in here. 5 times 6 minus 3, and then that's going to give me the answer they're looking for. Domains of functions. There's two things to look for. Variables in the denominator, radical, or sometimes we're going to have both. What do I do here? X plus 8 cannot equal 0. Solve for x, right? In this case, x not equal to negative 8, right? That is the domain. So all reals except for negative 8. So I can go from negative infinity up to negative 8, union negative 8, all the way up to positive infinity, if I'm going to do that in interval notation. All right, what do we do about radicals? A radical cannot be negative, which means it can be greater than or equal to 0. And I can solve for x. All right, now what if the radical is in the denominator? Well, it can't be negative and it can't be equal to 0 either. So what I'm going to do for this situation is I said 2x has to be greater than 0. Okay, greater than 0 because I can't have a 0 in the denominator. Not equal to 0. I'm sorry. Greater than 0 because I cannot have a negative in the radical. Not equal to 0 because I cannot have a 0 in the denominator. Right, so this would be then the domain for this particular function. And then I would write, let's see, x, then negative x greater than negative 2, x, flip the signs. X has to be then less than 2. So how would I write that? Well, I could go from negative infinity all the way up to 2 and be okay then for this function. Okay, we'll continue the next page on the next video.